Orchesty isn't just a platform that helps you build integrations. More importantly, it manages the entire integration lifecycle. And the largest part of that lifecycle is operating and monitoring integrations, as well as supporting their end users. As middleware, an integration platform sits between all the systems involved. Errors in running processes can have many different causes and may originate in any of the participating services. Orchesty provides tools that help you identify the root cause as quickly as possible, wherever it is. That's why Orchesty includes a range of dashboards, which we'll take a closer look at in a moment. But it also allows you to audit transferred entities across processes and inspect the overall state of the integration layer using chat and MCP. Let's start with the most important dashboard, the process heatmap. The heatmap is made up of rows representing individual process topologies. Each row is divided into time slots. Every slot shows how many processes ran during that time interval. A slot turns red as soon as any process within that interval ends with an error. This makes every error immediately visible at a glance. By clicking a slot, we can drill down and see exactly what happened. At the first level, we see a breakdown of individual process runs and their statuses. Let's go one level deeper and open a specific process run. Here we can see the connectors used by the topology, how they were called, and how many calls ended with an error. We can also see connector logs, and unless we removed them earlier, any messages that failed to be delivered. In the failed message detail, we can see its operational headers and the data itself. We can edit the data and send the message back into the process from the point where it failed. For now, we'll leave it in the trash and check whether this connector fails more often and what its statistics look like. Here we can see that over the last 24 hours, the connector made almost 15,000 requests. We can see that 483 requests failed with status codes in the 400 range, and that all of these errors occurred within a specific time period. Once again, we can also see the logs for failed requests and the messages that ended up in the trash. This particular error points to an incorrectly configured limiter, because the requests were rejected for exceeding the rate limits of the target API. You can learn how to work with rate limits in the fourth part of our tutorial series. Let's look at the other dashboard tabs used for monitoring integrations. In the next tab, we have similar heat maps grouped by application. Here, however, we are no longer looking at processes as a whole. The metrics are aggregated by connector calls. This makes it easy to see which integrated service had trouble accepting requests, or which connectors for a particular API are failing. The next tab breaks the data down by individual connectors and their statistics. We've already seen the connector detail that can be opened from here. Everything is naturally connected, and it simply depends on which perspective you need or which question you're trying to answer. The following tabs provide views based on topologies and then on individual process runs. The last tab is more operational and shows the current consumption of key platform resources within your cloud plan. All the dashboards we've looked at support different time granularities, so you can inspect data from the last hour, day, or even month. But dashboards are only one part of observability and auditing in Orchesty. Another option is auditing with a tool we call Trace. Trace is powered by an LLM in the background and lets you interact with the platform naturally through chat. You can ask Trace many of the same questions you could answer from the dashboards, such as whether any process errors occurred today, what they were, how many there were, and so on. But Trace also adds a key capability that dashboards don't provide: entity auditing. Entity auditing is based on one of the most common questions we receive when operating integrations: questions about data inconsistencies. An entity audit returns all data transfers for a specific entity within a defined time range across all topologies and processes. We can see what the data looked like at the input and at the output, and we can even define any number of checkpoints within each process to capture the state of the data at specific points. Trace can find entity transfers based on attributes that we define ourselves for auditing. This means you don't need to know one specific identifier. The attribute you search by doesn't even need to be present in every audited payload. For example, we can search for product transfers using a European article number, even if a topology synchronizing prices does not transfer this number at all. The data transfer will still appear in the audit. If you're wondering how that's possible, here's the answer. Entity auditing is not automatically part of every data transfer in Orchesty. First, we need to define the entity itself and the attribute keys we want to use when searching for it. Then, in the relevant topologies, we define so-called audit headers, containing one or more of these attributes. This tells Orchesty which entity the topology is auditing. After that, we simply add a single method at every point where we want to collect audit data and pass the audited data to it. Orchesty then connects the history of all related processes using these attributes. The result is a report that helps us identify where an inconsistency originated, even when no code error occurred. We can see what the source data looked like and exactly what data was transferred to each service. If you can imagine this level of observability and data transfer auditing making integration operations easier for you, try our trial.